On question 8, the radical expression has the 3 in front of it and has x minus 5 inside, so let's isolate this as much as we can. I need to move the x. Since it's positive, we subtract it. Now we can't really subtract it and combine it with 5, but we can put it after the 5 and subtract from 5. So then I bring down negative 3 square root of x minus 5 equals 5 minus x. Now, I don't really want to divide by the 3 because that creates fractions over here, but I can get rid of this negative that's here. What I can do is divide by negative 1 on both sides. That makes it positive 3 square root of x minus 5, so the negatives cancel. And then over here, let's go ahead and divide both terms by the negative 1. So 5 divided by negative 1 is negative 5. Negative x divided by negative 1 is positive x. So if I reverse that, I just get x minus 5 for that side. Also pay attention because that's not a cubed root, that's a 3 coefficient. So now let's get rid of the square root. Let's square both sides. If you're leaving a coefficient, you have to square it as well as the radical. So 3 squared is 9. When I square the radical, it brings out x minus 5, but I have to multiply by the coefficient still, so put that in parentheses. On the right side, we need to write the group twice. So a group squared, write it twice. Let's clear parentheses on both sides. So we get 9x minus 45 equals x squared minus 5x minus 5x plus 25. So 9x minus 45 equals x squared minus 10x plus 25. Now keep the x squared term positive. So that means that when we set this equal to 0, I don't want to move the 10x and 25 to the left. I want to come over here and I want to subtract the 9x from the negative 10x and add 45 to the 25. So then I have 0 equals x squared minus 19x, and 25 plus 45 is positive 70. So at this point, we need to factor this using the AC method. So AC, the A number times the C number, is positive 70, and then I want my sum equal to the middle B number, negative 19. So if we try to list factors of positive 70, we have 1 times 70, 2 times 35. 3 doesn't go into it, 4 doesn't, but 5 does. So 70 divided by 5 is 14. Now if I stop here, there's my 19, but I want the sum to be negative. So remember that second list is double negatives. So we want negative 5 and negative 14. So x minus 5, x minus 14. Set both of those groups equal to 0, so you get x is 5 when you add 5, and x is 14 when you add 14. So now let's go ahead and check these solutions in the original equation. So if I check 5, all the x's become 5s, so I have 5 minus the square root, or I'm sorry, 5 minus 3 times the square root of 5 minus 5 equals 5. So 5 minus 3 times the square root of 0 equals 5. The square root of 0 is 0. So when we multiply it by 3, we get 5 minus 0 equals 5. And that's true, so then I know that 5 works. So now let's go ahead and check the other solution that we got, which was 14. So I have 14 minus 3, square root of 14 minus 5 equals 5. 14 minus 3 square root of 9 equals 5. Now the square root of 9 is 3, so 3 times 3 is 9. 14 take away 9 is 5. So this is a situation where both of our values do work for the original equation.